Welcome to today's masterclass. My name is Lisa Richter and I will be your host today. On the off chance that you don't know about CSIA, we are a global nonprofit trade association with over 500 member companies in 35 countries. For system integrators, the CSIA Best Practices Manual and CSIA certification are some of the more popular member benefits, but they also enjoy a variety of others, including professional development, learning from their peers, and access to professional services experts, including insurance, financial, and legal, who understand the SI's unique business needs. For partner members, CSIA offers an ecosystem to grow their SI programs, understand their customers' pain points, monitor industry trends, and share their thought leadership. With thousands of qualified integrators and suppliers, the CSIA Industrial Automation Exchange helps SIs, industry suppliers, and manufacturers connect and do business. For SIs and partners, it provides a platform to support your content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. The good news is that we are now halfway through the year, and both membership dues and exchange profile upgrades are prorated, which is just a fancy way of saying they are half off. And we have put together a first-timer package for companies that join in July and August that includes some new member benefits, including an EPUB of new products and services called Innovation for Integration. The package includes a free listing in this new EPUB, but also some other goodies to help you get your message and brand in front of your customers. Get all the details at www.controlsys.org/shine. At this time, I would like to introduce today's speaker, Benson. Benson, take it away.
Terrific. Let's stop my video here and share my screen. And you should all be seeing my screen now. Welcome, everyone. Let's jump over to the PowerPoint. And there you go. Thank you for that introduction, Lisa. And thanks to CSIA for putting this event together. We're thrilled to introduce actually some new topics here, some new content relative to securing and democratizing data from Brownfield devices. So thank you all for attending today, and I hope you find this content valuable. Obviously, security is top of mind right now with everything that's going on, so hopefully this is also timely information as well. So we're going to go ahead and click forward here. My name is Benson Hoagland. I'm responsible for product strategy and marketing here at Opto 22. And I'm also pleased to introduce Ben Orchard, Senior Applications Engineer here, who is standing by to answer any questions in real time as we progress through the webinar. We'll also should have some time at the end for Q&A. Now, I'm broadcasting live from the Opto Demo Studios, kind of my COVID project. Right here from Temecula, California, where Opto 22 headquarters is. This is about 50 miles north of San Diego. It's where we design, build, and support everything we make. So made in the USA all the way. So what's the topics for today? Well, we'll spend a couple slides just talking about goals and technologies relative to the IIoT and digital transformation. We'll also take a deeper dive into cybersecurity, understanding what that means and what its effects are on the OT side of the business. We'll also look at democratizing operational data, and that's simply making data available and accessible in a meaningful way to applications that can use it. More on that as we move forward. And then we'll take a closer look and do a system architecture build. So you can see how the pieces kind of come together, followed by a live demo of how those pieces are actually set up. Then finally, time permitting, I've got a few slides about Opto 22 if you're new to us, and also about the products that are being used to demonstrate these capabilities. So with that, let's jump right in. 3 goals for the IIoT. In general, when you're trying to apply some sort of digital transformation or IIoT project, putting that together, you can distill it down to 3 primary goals. The first one is, of course, democratizing operational data, as I just described. And again, that's making data available and accessible to any applications that can use this. But the second one becomes critically important as well, and that's implement cybersecurity measures. because we don't want to just allow anybody to go get data from unsecure devices. We want to make sure that we do this in a very secure manner. So only those people that are authenticated, encrypted, and so on, or have access can get the data, but it should still be freely available. And finally, of course, the most important outcome of any project is to get the desired business outcome. And so these are basically the three goals that we see for IIoT applications. Then we're going to look at three technologies that help facilitate or help us achieve those goals. The first is edge computing. And this is just the notion of moving compute power down as close to the possible of where the data source is that you can. And if you think about edge computing, think about the smartphone in your pocket. It's a lot of compute power right inside your pocket. That is, in essence, a type of edge computing. Talk more about edge computing coming up. The second thing relative to technologies is the ability to do network segmentation or zoning. And that is to protect untrusted networks from trusted networks. More on this later, but in effect, what we want to do is protect assets that are in the so-called OT zone, where PLCs and so on might exist. That's a trusted network. We know everybody who's on that network. And we want to protect that from the IT zone. And that's like, say, the IT LAN. And this is an area where it's untrusted. We don't know everybody on that LAN. So we want to make sure that we can segment and zone those two networks appropriately, but still provide access. And the third, of course, is data communications. Once we've established an edge computing device, along with the appropriate network segmentation for cybersecurity reasons, now we can talk about how data flow occurs. And we'll be getting into that in pretty deeply. Now, in a previous CSIA masterclass, my good friend Travis Cox from Inductive Automation presented this particular webinar on leveraging modern technology to securely open access to data. Travis did a brilliant job here, and I highly suggest going back and viewing this webinar on CSIA's website. There's a lot of great content in it. In the next few slides, I'm going to reiterate some of his key points and concepts that he laid out to kind of set the stage how we're going to move forward. And the first one, of course, is what are the issues we're trying to solve here? Well, one of them is ICS attacks, or industrial control system attacks. We're all familiar with Stuxnet. We've heard that. It was 10, 11 years ago. And then the more recent Oldsmar water plant in Florida. Stuxnet was introduced through a USB key drive and targeted Siemens PLCs, where the Oldsmar water plant was a remote access application where the password itself was compromised and allowed somebody to get into the SCADA system. But a couple of lessons learned here. Number one, on Stuxnet, PLCs are vulnerable. It's just that simple. They weren't built for today's open networks or connectivity like they are being asked to, yet they're vulnerable, so we have to protect them. And also, air gap isn't necessarily panacea. I mean, a lot of people think that if you just air gap a system, you're good. The reality is that doesn't always work. In fact, in most cases, it doesn't. Over on the Oldsmar water plant, same kind of concept. You got to provide strong, unique user passwords, user authentication, and network segmentation. These things become very important as we're moving ahead. So what I would ask for you is to find out where your clients stand. You've got we got your customers that are implementing these types of solutions. They need data. They want to implement cybersecurity as part of IIoT or digital transformation. These are a list of questions we need to ask ask your clients. Are their PLCs vulnerable? Generally, yes. Are there shared weak passwords or perhaps no password policy in place at all? Is there central user management of the user authentication? Is there automatic logouts set up? Is there fine grained controls of the applications that may reside on a computer or an edge device? The reality is there's a lot of brownfield devices out there, and they don't necessarily have the modern open standards for protecting them. So what we want to be able to understand is take an audit of what's happening now and then talk about what kinds of technologies we can apply to address these issues. Another one is, of course, this thing called shadow IT. So I don't know if you've ever done this with one of your clients, but drop in a cellular router, connect it to the OT networks, you can gain remote access. Yeah, you're going around IT's back, and generally that's not going to end well. So that's one of the things that we see a lot, and people are trying to avoid. So hopefully we've got a solution there. All right, so moving on, how do we address these issues? How do we take all those issues on the preceding screen there and come up with a solution that's going to address all those and more? Well, we think that the way to do that is to consider edge technology, edge computing. And there's a whole bunch of advantages by putting compute down at the edge of network. Obviously, you're going to be able to pull data from Brownfield devices, from sensors and IO right at the source. And generally, you can be able to do that a lot faster than you're going to be able to do over a wide area network or a LAN. You'll be able to get access to this Brownfield data a lot easier. And then once you've collected that at the edge, then you publish the data up into infrastructure. So that could be, to a database, to an Mqtt server. It could be a number of different ways. And that's where we're getting to democratize the data. Now, one of the other kind of cool things about edge is a lot of these edge computers and edge devices have other capabilities on them as well. Lots of software, including the ability to write your own software. So if you wanted to write a C application or a Python script and run it down there, now you're able to analyze, transform, perhaps calculate, and condition the data before it moves on to up to the cloud or up to the DMZ for enterprise applications to consume. But the biggest thing about the edge computing, particularly with cybersecurity, is its ability to protect and secure unsecure PLCs and devices. This is going to be critically important as we move forward. And we want to do that with very secure, trusted methods that are widespread in other domains, particularly in IT. And finally, edge computing can also help us consolidate a lot of different operations and functions into a single device. Again, think like your smartphone. I can take a picture, I can listen to music, I can check email, I can do all these things with one device. Edge computing can help us get there as well. So relative to security you can trust, just as I said, we're talking about some of the same tools and methods that IT uses today on IT networks can now be pushed down to the edge. Of course, I'm talking about HTTPS and TLS, or maybe you've heard SSL. They're somewhat similar. Device and network interface firewalls. Firewalls are absolutely critical to block unwanted traffic coming into a given device, and then be able to create multiple network interfaces and segment or zone those networks. We're going to see more on that here in a moment. The devices should have a managed user authentication, not only on the local device, but also tied back to, Active Directory or LDAP or whatever. It should have automatic session timeouts. You don't want to leave these connections live all the time when they don't need to. And I'll try to abide by what's called the zero trust model. That means start off with nobody having access to anything, and then build from there and only provide access to those who need it. So relative to this idea of edge computing helping consolidate operations and functions, let's take a look at this. This is generally how things are done today. This is a conventional system where you've got a lot of pieces and parts that are kind of cobbled together to achieve a given objective. And obviously there's all kinds of issues relative to software licensing, Windows updates, multiple vendor support. Just getting all this to work can be a challenge. Recognizing that as a system integrator, that's one of the things that you do. But the other issue here is you notice the unlocked little red locks there. There are so many attack vectors that are apparent here because these devices weren't meant to be secure. And for that reason, you've got all kinds of issues once somebody gets onto a given network where you have vulnerabilities. So an approach with edge computing allows us to take a device, put it on the plant floor, and zone away or segment all of those unsecure devices, provide a lot of the functions that are in the top box into a single device, and then move the data on premise or to the cloud. Now, I'm not going to get away with saying, okay, rip out your existing architecture or infrastructure and put the shiny new edge device in and get rid of the rest. Obviously, we live in a brownfield world, so that's not going to happen. And that's where edge computing can come into play. It doesn't have to do the control, certainly capable of it, but it can also just protect the brownfield devices and pull the data in and get it where it needs to be. So this architecture here kind of shows it again a little differently. Again, where I've got my mouse pointer here. I've got my analog digital serial IO connected to IO cards on the Epic, on the Rio perhaps as well. but it's not required. Don't have to have IO on this system. I'll show you later. And then you can connect one of the network interfaces to various control and IO networks. That comes into the device, all behind a firewall. And then you have various software that can do whatever you need to, real-time control, to Node-RED for moving data to a database, to Ignition, all kinds of software tools on there to then push the data to the corporate network or whatever network. And that could go to on-premise applications, in the cloud, and even push data directly to devices. So the other problem that we have in traditional architectures looks like this, and that is simply that systems tend to be very tightly coupled. So a piece of software needs data from a PLC, a connection is created, and you're polling the PLC to get the data into the applications. This is very common in SCADA. So the problem with this, of course, is it doesn't scale. It's very inefficient. It's continuous poll and response. You have a lot of point-to-point connections, and those are all unencrypted traffic. So anybody can, essentially attack, the man in the middle of attack, as they call it. And then there's all this problem with all these ports open in the system that permit these kinds of communications. It's an IT nightmare. And when you ask for an IP address from IT, in fact, you're essentially shifting the responsibility of protecting those devices to IT, and they hate that. Another approach would be something that, like what you see here. This is a pub sub model, but what's important is the applications on the top are decoupled from the devices on the bottom. The coupling happens in the middle, and that's where in this case, MQTT, doesn't have to be MQTT, could be other methods, but we're going to talk about MQTT here. This is a very highly efficient pub sub model that is bidirectional, and it only transmits data on change. And that's one of the reasons why it's such high performance. You're going to get to see that later. But the really critical thing of this architecture is its security. There are only one open port in this system right here at the broker. Or if you have multiple brokers, each of the brokers redundant, whatever. But all the ports, all the inbound ports for any of the devices or any of the servers can remain closed. And that, of course, significantly clamps down the attack vector from a bad actor. This is also much simpler to maintain and manage because now we're at the source, at the data source where the PLCs exist. We're collecting the data, doing whatever we need to do, and then push it up into infrastructure. And when we do that, all those tags instantly become available to any application that needs it. So a couple of guidelines as we wrap up this portion of the presentation, applying security best practices. Number one is training. There's no question about that. You have to train your customers. You have to train your clients on OT security and IT security. And the good news is those are kind of coming together. So we're seeing, again, more IT security capabilities down at the OT level. Avoid shadow IT and removable media. There really isn't any reason to do shadow IT anymore with these edge devices. There's ways to do this now securely, which I'll be showing you. Segment your networks into secure zones, separate and isolate the OT network from the IT network, and protect those PLCs that are largely unsecure. And then encrypt all the communications with well-known technologies like TLS. Authenticate users against Active Directory or LDAP, or even to the local to the device. And then leverage MQTT to push the data out an outbound connection to a MQTT broker or server, and then allow any other application to subscribe to that data securely. And finally, use devices and applications, both that have inherent security built in. This is important. Bolt-on security is just proven to be ineffective. So we want to be doing this with native devices. Okay, terrific. So we're going to jump into a quick system architecture build out. We'll start here with, of course, the field devices, the assets that you need to get to, whether that's plant floor equipment, OEM machinery, maybe remote geographically dispersed assets like a tank or a wellhead. And then we're going to build an OT zone. Now, the OT zone, of course, is where we're doing our controls, and it needs to be isolated from all other networks. And generally within this zone, you're using static IP addresses, as you'll see in my demo, because DHCP services are generally kind of rare in an OT environment. They sometimes exist, but a lot of times you'll see a static IPs there. Now they're in this zone. There's potentially a lot of unsecure devices like a Modbus TCP device, not secure. So you want to make sure that we're protecting that and making sure that even in any of the industrial protocols that are in there end up being isolated from the rest of the network. Now, obviously, this is about incorporating brownfield devices, so we need to integrate legacy assets as well. And so what you see here is the same kind of idea. Actually, this is using an edge compute device called an EPIC without I/O, just the main gateway computer, and then it's isolating existing PLCs again in its own zone. In fact, these are two different zones. So we're doing a lot of network segmentation to really truly protect the system. Now, also in this zone may be a PC, kind of like this PC that's behind me in my demo. I'll be showing that as well. That's also a zone for, say, doing your programming or doing troubleshooting right within the zone, but no access to the internet. The next step, of course, is on the other network interface of your edge device. There's plenty of them there, and I'll show you coming up soon. We'll connect to another network. In this case, IT LAN. Remembering that the IT LAN is untrusted. I know everybody who's on my control network, but I don't know everybody who's on this LAN. In fact, in this picture here, this PC that's right here in the middle, that's the PC I'm presenting from. It's on this IT LAN. But that LAN's connected to my Epics, but I'm only going to allow access to any of the Epics or edge devices with security, authentication, and encryption. So then I'm segmented from the OT network and protecting those unsecure PLCs. Okay, so moving on. Oh, a couple of things on the this notion of connecting to the IT LAN. You might be thinking is like, well, wait a minute, how do I protect the device? A couple of things. One, firewalls. I'll show you how that works. Certificates, user authentication, and of course, the ability to have completely segmented networks. So they're not electrically tied to each other. So those are some of the features that you'll see on edge devices that help facilitate that isolation. All right. Now what we've done is once we're on the corporate LAN, that generally has a gateway to other network services that might be available. Could be on-prem in the so-called DMZ, could also be in the cloud. Here's the good news. With these kinds of architectures, it really doesn't matter which one it is. As long as there's a gateway to those networks where those servers reside, you're in good shape. So it could be an open VPN server for VPN connectivity. We'll show you that. Could be MQTT for, again, moving data around. In fact, I'll move it to the next screen here, showing that indeed we've got MQTT messages that would move up to a MQTT server. And then again, that could be on-prem or in the cloud. And because there's already a firewall on all these devices, it won't allow anybody to go and connect to those things unless they're secure, unless it's coming in through a secure port. More on that in a moment. But this also facilitates cloud connectivity, and then we can add SCADA. In this case, I'll be illustrating using an ignition server to connect to the MQTT broker and subscribing to all the data tags being produced by the protected OT devices in the OT zone. And then I'll also be showing you how I can move that data actually to standard OPC UA clients. But the other cool thing here, of course, is other applications that are MQTT aware. In this case, I'll show you the Canary historian that is making a direct connection to the broker to get the data it needs, not to the devices in the OT zone. So this is a completely decoupled environment, 100% secure, and all the traffic is device originating, moving into the broker to consume the data, yet still bidirectional. All right. The big thing, of course, with IIoT and doing these types of architectures is scale. It's got to be able to scale easily. We can't, spend all our time putting one zone or one cell together. We've got to provide an architecture that allows us to quickly add other devices, bring them online, publish their data into infrastructure, say again to an MQTT broker, and then automatically SCADA and other MQTT applications can consume the data. No reentry of tags. It just pops in and magically appears. I know it sounds crazy. It's exactly how it works. Finally, once we start getting some of these architectures in, we start to address the issue of remote access. So now, using well-known and trusted VPN technology, I can fire up a remote access computer. We all been working from home lately. Fire up our PCs, connect to the VPN to maybe the corporate office or whatever, and get into the office network. Well, the same can be done now because edge devices have VPN clients as well. So we can spin up those VPN clients. They make a connection into the VPN server, again, in the cloud or on-prem, and then your remote device starts up its own VPN client, and suddenly you now have, as indicated by these orange lines, you have connections to your devices securely and encrypted. And just to note, VPN is a trusted network because we know everybody who's on that network. They must log in, they must provide a username and password, and it's all encrypted. All right. The real kicker on this thing is the ability to temporarily create something called conduits. So we have the two zones, as you see here, but in some cases, I may need to get to that remote PLC in that protected zone on a temporary basis. I need to, do troubleshooting or whatever. Well, once I've spun up the VPN tunnel and I'm completely secure on that zone over to the OT zone, I can create these conduits that allow me to, on a, again, temporary on-demand basis, be able to reach a PLC. So those are the kinds of things you're seeing with edge compute and the kinds of architectures you can build for securing your devices and democratizing the data. That's going to take us into the live demo. So I'm going to jump into that now. Let's go ahead and pull this up. And I'm going to switch to this screen and switch it around. Now, one of the things I'm going to show you, let me switch that back. I'm going to come over here to this diagram. This one's on our website right now, and it's basically the same thing you saw on the slides. And this is kind of the situation or the application I have here beneath me. You see that down beneath me here is my live demo. The first one is an Epic connected to an Allen Bradley and Siemens PLC. As you can see, there's an Epic edge device communicating to two unsecured PLCs. And what's important here is those are in the OT zone. So the OT zone is basically this blue cable coming from one interface over to the PLCs is on its own segmented interface with a static IP address. I'll be showing you that in a moment. And if I come over here and look on the IT network, I'll be connecting to other services, a VPN server, an MQTT server, and so on. I'm doing that over the yellow cable, which is my IT LAN. It's also where this PC I'm presenting from is on that LAN. So that's an IT network and so on. There's some other stuff going on here. This is running a control program to operate this turbine. It's sending data to SQL, it's sending data to MQTT, all kinds of stuff, and even a local HDMI interface for a touchscreen, local touchscreen that could be mounted on the outside of a cabinet, whatnot. So more on that in another webinar. So what I'm going to do now is I'm actually going to log in. So as I said, I'm on this PC right here. My arrow is probably a little small for you to see, but I'm on this PC right here, and I need to log into the Epic. To do so, I need to do so securely because I'm on an untrusted network. I'm on the IT LAN. So let's go ahead and do that. What I've done is I've created a shortcut here, and boom, I come in, and the first thing you want to look for is, am I connected securely? So there's a little padlock up on your browser. It lets you know whether or not your connection to the device, to this server, is secure. And indeed it is, because I received a certificate from my IT department, installed it on the device, and confirmed that this is the right server. And now I have an encrypted connection. Now I can safely enter my credentials and log into the device. But what I'm going to do here is not log in with a local account. I'm going to log in with Active Directory. So this is my Opto 22 Active Directory credentials. I'll go ahead and log in. It confirmed against the LDAP server that I'm valid, that I have a valid account to log into this device. This is important because, I just read a report yesterday on LinkedIn that said that 1 out of every 4 ex-employees still have access and privileges to their old jobs, to the servers and services on at their old jobs. It's nuts. Centralized management allows you to take care of that. So I definitely recommend using things like LDAP to centrally manage user authentication. So I'm in the device now. I'm going to click into accounts. And yes, I have a lot of local users with various rights and privileges. And then I have my LDAP users here. These are users that are centrally managed, including this manufacturing user here that we may be able to get to later. So user accounts and user authentication is absolutely critical on devices, particularly at the edge. And that's that first, those are 2 steps of security there. 1, encryption, 2, logging into an account. The next part is, well, how did this thing actually get on the network? So let's take a look at the network settings here. And here they are. I have on the Epic itself, I've got 2 Ethernet, gigabit Ethernet interfaces, a Wi-Fi interface, and an open VPN tunnel. Of these, the Ethernet 0 is connected. That is my OT network zone. So if, again, if I switch to here, that's this blue cable. That's my OT zone with a fixed IP address. The next one is my Ethernet 1, which is connected to my IT LAN. In this case, I obtained a DHCP address from IT, just automatic, just dynamic host control protocol. And I can pull down, I get an IP address, but more importantly, I get a valid gateway to other networks. Could be to the internet, could be to the DMZ, whatever. It's just a path to get to other networks. And finally, I've got this open VPN tunnel, which is already started and running. That also is getting its address from the VPN server. And note its address is different than the other 2. So I have 3 network interfaces allowing me to zone and segment those as appropriate. So right now, in this case, Ethernet 0 is a trusted network. It's unsecure devices, but I know everybody on that network. Same with VPN. It's a trusted network. I know everybody on that network. IT LAN, who, good, anybody's guess. So that's how the networks are set up. Once they are, the next critical thing, of course, is security. And by that, I mean the firewall. And this is where things get interesting and where the power of the system comes into play. I told you that I connected to this device on HTTPS port 443. That's because it's encrypted and secure. I have to authenticate. So in that case, I will allow all the interfaces, all the ETH0, ETH1, and Tunnel 0 to accept connections on that interface because I know they'll be encrypted and secure. But Modbus, no, that's not secure. If the protocol is not secure, generally devices that listen for Modbus, Modbus slave, they are not secure. So I don't want anybody to be able to access those devices on ETH1, in this case, WLAN 0. So from the corporate IT network, I can't get to those devices. I'm blocking all requests. Same for my controllers. I've got 2 real-time controllers, control engines on this device, my CodeSys runtime engine and my PAT control one. Same thing, deny on ETH1. Don't let anybody on the corporate LAN come in and get to my control program. They can get to it through the VPN tunnel. So as you can see, I can get to it from the tunnel, from the VPN side. That's how we're going to permit access. That way, we've now taken unsecure devices, whether it's the control program or the PLCs on the other side, and now we have controlled access to those from anywhere. Same thing with some of the other software that's on the system, including Shell, where you might run your own applications, the Ignition software, and so on. So there's lots of capabilities and granularity relative to what kind of access you're going to permit to this system. Now, while we're in security, it should be noted that when you come up with the idea of certificates and security, a lot of people, or particularly in OT, are like, "Oh, that is such a nightmare." I agree. It could be simpler, but it is what it is. So we want to make the tools as simple as possible for you to obtain certificates and get them put into the system. And that's what this screen is here. You can create certificate signing requests that you send up to your IT department, and IT will respond with a certificate. You upload the certificate and you're good to go. So lots of nice tools in there to make security at least a little easier than it usually is. All right, so I've gone through all of that. One of the things that I talked about earlier was this idea of a conduit from 2 different interfaces allowing traffic to go across on a temporary basis. that's done here. And as you can see, there's no rules in there now, which is how it should always be, unless you need to access something on the other side. Hopefully we'll have time to get to that and show you how you create those rules and gain access to PLCs on the OT zone from the VPN network zone. Okay, terrific. Now that we've got the security portion kind of taken care of, let's talk about data democratization. So I'm going to go in here into MQTT, and there's a lot of different ways to publish data from this edge device into an MQTT architecture. There's this native client here, which will take all the data from, say, the local pack control or other, basically pack control or any of the IO, and push the data up. And it's pretty simple. I just fill in the blanks of my topic namespace. I point it to where the broker is, and I set it up to be secure and give it a username and password. And as soon as I start this thing, the Epic itself as a client will be a device originated connection outbound to the MQTT server, log in securely, and leave that connection persistent. Persistent simply means leave the connection open. That way I can allow data to come back if I need it to. So if I need to set a set point from SCADA, or I need to toggle an output, whatever it might be, I want to keep that connection persistent. And the other advantage of the persistent connection is simply that I always know the state of the system. If a connection fails, I can assume that its state is no longer valid. And that helps us understand as a whole how the system is operating. Okay, there's other methods like Node-RED. We have a built-in Node-RED environment on this, so I can publish data to SQL databases, to MySQL, to Influx, to APIs, all kinds of capabilities there. But one I want to focus on here is something that's a very rich piece of software, particularly in SCADA, and that's Ignition. Indeed, we have Ignition Edge preloaded and installed on the device, ready to roll. This one is already running and configured, but I want to show you a couple of things there. Now, why would you use Ignition Edge in this environment? Well, the primary reason is because I need drivers to the AB and Siemens PLCs. So there's a couple of ways of doing that. Ignition is the far simplest way to do it, but I possibly could use Node-RED to go get the data and so on. So there's a lot of different ways to do it. We're going to focus on the Ignition method because it's the simplest. So I'm going to come over here to config. And what you'll notice is I have to log in again. Remember when I talked about granularity on applications and devices relative to authentication? Here's another example of that. The Ignition Edge software also requires me to log in with a valid username and password. Okay, so I'm going to go over here to the status screen and just give you a quick look around. There's kind of an overall view of it, but I want to go into the devices. In other words, what is Ignition Edge communicating to over that OT network zone? And indeed, if I come into the AB PLC here, I can see that I'm pulling 5 tags out of there. But what's important is, how did I configure that device? This is how. I'm on the AB driver now. I'll go ahead and click Edit, and I simply give it a name. I say that it's enabled and its IP address. And if you remember, the IP address, that is in the same fixed IP address space of that OT zone. So now we're using essentially 1/2 of the Epic to talk to the OT zone, pull the AB data tags in, and then we'll take those tags, push them out over the other interface. And as you can see over here on the status page, clearly even Ignition Edge can see all 3 interfaces. So it gives me a lot of flexibility of how I deal with these, deal with the interfaces. Okay, so I'm gonna scroll down here to MQTT Transmission. This is another MQTT SparkPlug-B client. And this one's pretty straightforward. Enable it, determine where the tags go and what the topic namespace is, and let her run. And it's going to take all the tags from AB, from Siemens, even from the local control program, and publish them up there for other applications to consume. So what does that look like? How do we get the data to where we can actually do something with it? Terrific. So I'm going to come back to this screen here. And as I just indicated, I had one zone here that's moving data into, grabbing data from PLCs in a local control program and moving it into infrastructure over MQTT. I've got another one over here that's on my, my so-called cooking cam, which looks like this guy down here. And this is just a Rio that's connected to an Allen Bradley PLC and doing the same thing, pushing the data right into the MQTT broker. So let's do something with that data. So what I'm going to do is I'm going to fire up SCADA here, which is IT4, and we're also going to go IT4 MQTT. So now I'm going to log into this server here that's an Ignition server that's connected to the same broker. So I'm going to click here, very quickly go into the gateway for this particular server. Yes, as you can guess, I need to log in, so I'll go ahead and do so. Everything is secure, just as same with the padlock up here. And this is a public website, so you're going to be able to get to this in a little bit. Same thing here. I have an MQTT called Engine, and the engine, I just point it to those same servers, and suddenly this gateway, as indicated down here in SCADA, is able to consume data from everywhere. So all the devices that are publishing into the broker are now available based on username, password, control lists, access, all of that, all built into MQTT. I'm able to get to that data. So let's see what that data looks like. Now, what I'm going to show you is not an Ignition HMI screen. I'm going to actually show you our Groov server for Windows Windows application running on this same server. That's an OPC-UA client. That means it's getting its data from this Ignition server, which is actually MQTT data. Let's take a look. I'll go to demo.groov.com. I'm going to go to the home page. Actually, I should have been logged out. I'll go ahead and log out because you want to be logged out on these types of systems and then be able to log back in. We're going to provide a username and password for you to actually do this on your own and see how this works. I'm going to come in here into the Epic Turbine. So on that home page, I'll just back up since I clicked kind of quickly there. Down here is an Epic Opto Turbine. You'll want to click on that, and voila. What I have on the screen now is all the data from multiple devices all funneling in to one dashboard. And this dashboard is getting all of its data from the broker. So there's nothing tightly coupled. We're not talking directly from this gateway to a given device. Everything is secure and everything is encrypted. So when I come back to this, I can see that, whether the turbine RPM, the wind speed, I can see temperature from the Rio. I can even see the stock of Tesla right now, which is, it's up a little bit today. And that green stack light in there is one of the green stack lights indicates that the stock is up. And that's from Node-RED. So again, another way of data democratization. Okay, but one of the reasons I bring this screen up is not because, not only is it a great dashboard of what's happening across a bunch of devices in SCADA, but it's because it's a terrific way to show you the performance of the system. When you talk about encryption, you talk about certificates and user accounts and all this, seemingly heavyweight stuff you're putting onto secure devices, your first thought might be, well, that's not going to be very high performance. That's not going to be fast enough for SCADA. I think I can prove that that is not the case. For example, on my screen below me, and I'll just switch again here. So I got my finger up here. There's a couple of stack lights up here above these PLCs. The green stack light's wired to the Siemens. The red light is wired to the Allen Bradley. This, of course, is communicating over the OT network to the Epic. The Epic is running Ignition software, scanning this on the trusted OT network and publishing data on change out to the broker. So that's all good. Now, this connection is also persistent, meaning it's always on, so I can actually receive messages back and send it out to the PLC. Let's take a look. When I come back to my main interface, I'm going to show you a PC here that's logged into the Groov, that other tab, that Groov view for a Groov server for Windows. It's going to send a command to the Ignition gateway. The gateway is going to convert that to an MQTT message. The message will then be subscribed to by the Epic in the field, and the data will get to the PLC, all securely, all encrypted, all on the user authenticated. So let's come back to my screen. So if I want to turn on the AB stack light, the red stack light there, I'm going to count it down for you. And Take a guess at how long it's going to take to actually occur. 3, 2, 1, click. Pretty fast, huh? In case you missed it, the screen beneath me here is a high-speed real-time feed. The one in the browser is a little bit slower. So let me do it this way with turning off the green stack light on the Siemens. 3, 2, 1, click. It's almost instantaneous. It's astonishing how fast and powerful and efficient MQTT is. So don't think that by applying all this security and applying all these user authentication is going to slow things down. It's giving me now access to PLC data, be on the right to a PLC because I'm authenticated in very, very high performance and very, very securely. So that's pretty slick. Now, the other thing is I mentioned that the Canary Historian, I can get data out of the broker for that too. Again, this decoupling. So let's go to the Canary Historian. I'll open up a new tab and I have a shortcut for that as well. And of course, on any server, you want to make sure you log in. So I'm going to go ahead and log in here and I'm going to pull up a trend. Now this trend is showing me the temperature from the Siemens PLC. There's a thermocouple connected to it. I've got a waveform in the Allen Bradley PLC, and I've also got the stock ticker of Tesla, all on one Historian, completely decoupled, not part of SCADA, just Historian working on its own because it's MQTT aware. So that provides a lot of power and capability for viewing a lot of data from a lot of different sources. So for example, I have an Epic in my home and I'm moving data up to the broker. And I've set up the Canary Historian to subscribe to that data. And we'll just go ahead and take a quick look at one of those pens. So, or one of those charts. There it is, Hoagland KW. And this is the real-time energy in my home. Looks like my pool pump is going on and off, and whether my water heater recirc pump is running. So it just kind of get a sense of the power and capability of decoupling, of moving data into infrastructure, and then having other applications subscribe to that, all done securely. Okay, that was a lot to go through. I've got a couple more minutes. I want to jump back to the presentation slides for a moment. So let me click back over to here. And pull up my, real quickly about some of the products I just described. I'm not going to get into a big product demo or sales pitch here. I just want to make sure you're aware of some of the products that are being used in this in these architectures. So we'll do that here. The primary one is the Groov Epic, of course, a real-time controller, edge programmable industrial controller, and Groov Rio, which is here on my cooking cam next to me. Epic is an edge programmable industrial controller. It is an edge device that has all of these features built into one system, this idea of consolidating a lot of functions into a single device. And then if you don't need the IO, the Epic is available in what's called a chassis zero configuration, allowing you to gain access to all the HMI, the gateway features, the HDMI, and the other software tools that are on there. A lot of features, and won't be going through all of these, but suffice it to say, this thing is industrial. It's minus 20 to 70 degrees C, class 1 div 2, UL ATEX, Linux-based, industrial Linux with a power fail-safe solid-state drive, oodles of RAM and memory and disk space. This is really a small computer that is designed to run on the edge. And most importantly, it's cyber secure out of the box. User accounts, both local and centralized managed, network zoning, configurable firewall, certificate management, it's all built in, all ready to roll. And of course, with the Epic, you also get the advantage of the HDMI ports. You can take anything that's on the front screen and expose it or externalize it to the outside of a cabinet. And then you got lots of different software titles on here that of your choosing. Pick the right software for the job. You want to do high-speed control, maybe go with CodeSys. You want to use a process control application, consider Pack Control. You want to write your own application, knock yourself out. All that stuff's in there. Same with the Rio. Rio is a rugged remote IO for the IIoT. What's unique about this product is that it, again, combines a bunch of those features into a single device up to 8 channels of software configurable IO. So I can get, as this previous screen showed, up to 200,000 different unique combinations from a single part number. So here again, cybersecurity out of the box, software configurable, 8 channels of all kinds of channel types. They're all in there, lots of information on our website. And speaking about our website, very quickly about Opto, we've been doing this a long time. We've been in it for 47 years now, 1974. Yeah, that's about right. So maybe a little bit longer. One of the things we're known for is quality and reliability relative to our IO, backed by a lifetime warranty. Hundreds of millions of IO systems out there at over 10,000 customers worldwide. But what a lot of people don't know is that even though Epic is our latest innovation, we've been responsible for a lot of innovations in the space. And, Ethernet IO in the 90s, we were a founding member, one of 4 companies who actually drafted the first OPC spec. So us and Microsoft and a few other companies did that right down the hall, as a matter of fact. And of course, what we're talking about today is the Epic. Now, some of you on this call, or most of you, are system integrators. You should know we have a terrific Opto partner program. I invite you to learn more about it. Perhaps some of you are on the call are already Opto partners, and you're IoT certified, which means you understood everything I just said relative to securing and democratizing data. But the point is that we have some IoT certified partners as well that know how to put these kinds of systems together. Finally, I'll just say that there's a lot of resources that are available. Ben will be dropping some of those, or he can drop some of those in, but this PowerPoint will be available to you afterward. And there's white papers, case studies about folks putting this stuff together, a link to that secure architecture build out. And it should also be noted that I did this entire presentation from a learning center. So these learning centers are available from us for sale. And the complete system, all ready to roll. Just plug it in. It lights up all blue, just like that one does. And it allows you to test all of these concepts and ideas with no other outlay than the cost of the learning center. So something to check out of there as well. Great. So that leaves me a few minutes for questions. One of the things I did want to do, I'll switch back to this screen here and bring up my browser because I wanted to allow you guys as well to be able to access this live demo. And so there you go. While we take some questions, feel free to point your phone or type in demo.groov.com on your web browser. And you'll be able to get in and actually control the turbine, see the Allen Bradley data, turn the stack lights on and off yourself. So we're going to jump into Q&A. Ben, are you there?
Yes, Benson. Sorry for the delay. I was just dropping a few links into the chat there for everyone to pick up. Benson, one of the questions that come up pretty often is just how is this possible to have bi-directional control if the firewall is shut?
Oh, go ahead.
Yeah, so if you could just explain that, because it's pretty interesting.
It is interesting, and so think of it this way: you're on your computer in your home, maybe at work, and you're connecting. Oh, somebody just turned on the turbine, and you're connecting to, say, Google to do a search, right? So you're able to connect to Google, get the search results, comes back to your PC, and boom, now you know where you can buy, a cat litter, whatever. The point is, you never had to open up a firewall port on your router to allow that to come back in, because you initiated the connection and accepted the response over the same connection. It's exactly how MQTT works. When it first logs onto the server, it creates a connection and leaves it open. So if commands need to come back through, I can subscribe to those commands, never opening up any firewall ports on the client. The client in this case, of course, is the Epic. The client is the Ignition Gateway. The client is the Canary. One of the things I've been saying lately is there's too many servers in OT. A PLC is a server, a Modbus device is a server. There's so many servers, and servers are vulnerable. Let's reduce the amount of servers, make everything clients. So in the systems I'm describing here with this interface, is one server and a whole bunch of clients. So that's hopefully that answers the question about how we obtain bidirectional communications with MQTT.
Yes, thank you. And so I take it then that there's some question about, well, what about the VPN? So that sounds a little bit similar, because it'll be outbound from the edge device up to the VPN, and so that enables two-way communication and control then, right?
That's exactly right. VPN tunnel is actually creating another network on top of a network, a secure encrypted network. It's the same one that you might use. You use your standard Ethernet cable connected to your router or Wi-Fi, and then on top of that physical media, whatever it might be, I'm going to spin up a VPN tunnel, encrypted traffic tunnel to move data through. So what you can see on the screen now is how I might use a remote access computer here to log into a VPN server with two-factor authentication, user pass, all of that, and gain access to devices out here. And the reason is because the same way MQTT works, the VPN client will initiate the connection outbound to the VPN server and keep that connection going so that I can tunnel back in. I actually have a really quick demonstration of that. Here's a Windows server. I'm RDP'd into a Windows computer. And as you can see there, it's just, I think it's still even Windows 7. And if I go into a browser, this particular computer is on the network, but it's not connected. I can't connect to any of the secure devices because I'm not on VPN yet. So you can see I'm trying to hit the address, but it's not going to go. So what I can do is fire up my VPN client. So this is like that remote desktop that's being shown in this illustration. Go back to it. I'm going to go back to the remote desktop. I'm going to fire up my VPN client. It's going to force me to authenticate. So I want to go manufacturing. I always do that. And I'll put in a password. Now, for this demo, I did turn off two-factor authentication just so the demo would go a little smoother. But generally, that would come up and say, enter a code. I do, but here you go. I'm now connected to the VPN. So as you can see, I've made this connection between the remote computer and the VPN server. And because this device is now on the network, it should pop up. Yep, there we go. And now I've made that connection through the VPN tunnel to the secure server. So this is kind of double secure because I'm communicating to it. Now I can, once I'm in here, I obviously can log in using LDAP. And I can get into Groov View and I can see my PLC data. So I can turn on and off my, I'm just going right to the local HMI that's on the device in this case. So I'm literally logged directly into the Epic on this screen here. In this case, I'm logged into this Epic here. So pretty cool. What's
All
more?
outbound, and the IT guys love it because there's no pinholes or port forwarding or anything like that, right?
No shadow IT. Absolutely. So this is all 100% secure, and all the tools to do what I've just done are built in. There's no extra cost for the VPN. There's no, obviously you need a VPN server spun up, but even in that case, OpenVPN Cloud offers up to 3 connections for free. Same thing with MQTT. I can spin up a HiveMQ MQTT server for free for up to 100 devices. There's really no excuses not to test this out and see how powerful this technology is, because there's so many ways to get started. So, with the Groov Epic Learning Center, a free OpenVPN server account, a free MQTT account on HiveMQ, and man, you can test all this out on your bench and then go to your customers and your clients and say, I've solved the problem of securing your Brownfield devices and getting the data where it needs to be. And that's what this is all about.
That seems like a really good ending there. A nice upbeat ending. Thank you so much. Sandra, if you could put up our last slide, I would appreciate it. I'm going to kick Benson off.
Let me stop sharing on my screen.
Thank you. Awesome. Okay, so on behalf of CSIA, I would like to thank Benson and Ben for this informative discussion. I'd also like to thank Opto 22 for sponsoring this event. And of course, thank you for attending. I'd also like to remind you that a recording will be available for viewing within the next couple of days. And be sure to bookmark the CSIA events calendar so you don't miss any upcoming events. This concludes our program for today. Once again, thank you for joining us and have a great day.
Thank you, everyone.